We now have more than enough information to figure out, by looking at the graph of the polynomial, what its expression is going to be. And to go about it, we're going to primarily focus on the zeros. We'll think a little bit about the end behavior at the end, but it's mostly the zeros that are going to do it. So let's take a look at this graph. This graph has two zeros. One here and one here. So it has a 0 where x is -1 and a 0 where x is 2. What are the multiplicities of those zeros? Well, this one is definitely 1. This looks like a straight line. Only x to the first looks like a straight line. This one is definitely even. We're going to guess that it's 2, because 2 is the smallest even number. Hopefully that'll work. If that doesn't work, we'll try another number. But it also looks pretty rounded there. It doesn't look flattened like x to the 4th would. So we know that our function, assuming that all of our guesses about multiplicity are right, is going to be f of x is some number times x minus -1 is x plus 1 times x minus 2 to the 2nd power. Now we just need the leading coefficient. To find the leading coefficient, we're going to pick some other point on the graph, some point that's not 0. And it looks like in this graph, the points we have to play with are this one and this one. So let's see what we've got here. I'm going to use the y-intercept first. I see that I have the point 0, -8 on my graph. So f of 0, that should be a times 0 plus 1 times 0 minus 2 squared, ought to be -8. Well, that means that a times 1 times -2 squared is -8. So that means that 4a is -8. A should be -2. We're just plugging in what we know, and we're doing some algebra. Our guess is that f of x equals -2 times x plus 1 times x minus 2 squared. Now, this was a guess, so we need to check. To check, we're going to choose another point. And the other nice point it looks like we have is that's 1, -4. So we're going to find f of 1, which should be -2 times 1 plus 1 times 1 minus 2 squared. That's -2 times 2 times -1 squared. That is indeed -4. So that checks out. If we had the wrong exponent there, something would probably have gone wrong in the process of plugging that in. If we had a third nice point, we might try that. It doesn't look like we have a third nice point. We are now pretty sure that we have the expression for this function. We have f of x equals -2 times x plus 1 times x minus 2 squared. And again, the reason we had to check with a second point is that one of those exponents was a guess. But here we are. So how did we go about this? First we looked at the zeros, and then we guessed the multiplicities from the shape. We put those into an expression for the function, found the leading coefficient, and double-checked. One last double-check we can make is to think about the end behavior. If we were to zoom way out on this graph, this looks like this if we ignore all these uppy-downy bits in the middle. And this is an odd degree at x to the third, x to the fifth, and it's upside down. So we want a negative leading coefficient. We expected an odd degree and a negative leading coefficient. What we got was degree 3 and leading coefficient -2. The end behavior checks out as well.